Okay, I think we've got quite a few people online, so I think let's get cracking. We've got quite a lot to go through. So again, welcome everyone to this long-awaited session on black soldier flies. We've been excited for this session for quite a while. I'm Christopher van Schalkwyk. I am from ASIN, and I'm joined with a few experts in this black soldier fly sector for today. So just some housekeeping rules for now. We'll keep everyone muted and the videos off, but in the Q&A session later, we will open the mics and we'll open video to get some interaction going. So you can look forward to that. And then the session is being recorded, so the recording will be sent out to everyone that's registered and might not be able to make it, or if you want to review anything afterwards. So the recording will be sent out. So then just quickly looking at the agenda for today, I'll quickly do just a quick welcome and a introduction to ASIN and what we are. So the African Circular Economy, or ASIN for short. So what we do. And then I'll hand over to Piotr just to set the scene for us and give a bit of introduction on black soldier fly, then what we can expect for today. Then we'll hand over to Marielle for some substrate chat. That will be quite an exciting one because I think there's a lot of misconceptions about substrates and black soldier flies. And then we'll go over to business models and operational insights from Daniela. And then we'll get some practitioner perspective and insights from James from Kenya. So looking forward to hear about his black soldier fly operation in Kenya. And then, like I said, we'll head over to the questions and answers and some speaker reflections to close off with. So then just to jump into the ASIN overview. So like I said, the African Circular Economy, or ASIN for short, is Africa's original think and do tank for circular economy transformation, connecting over 1,000 practitioners across 42 countries while delivering tangible impact through project implementation, research and knowledge sharing and capacitation. So our vision is to build a restorative African circular economy that generates well-being and prosperity inclusive of all its people. And then we work towards this vision, towards a restorative African economy through new forms of economic production and consumption, which maintain and regenerate its natural resources. So these are the strategic pillars that we use to work towards this vision and mission. So we call it the Connect, Transform, and Empower pillars. So on Connect, we build and strengthen this comprehensive network of circular economy practitioners. We foster collaboration across the countries and sectors and also different stakeholder groups. In the Transform pillar, we deliver impactful programs and projects that translate circular economy principles into tangible business models, policies, frameworks, and systemic change across Africa and communities. And then the Empower part, of which this session also falls under, we equip stakeholders with knowledge, skills, and the tools needed to become effective circular economy champions and implement in their respective context. So that's also an important part, and what we would like people to take out of this session as well is take this knowledge that you gather from these sessions and actually go and implement it in your local communities. A quick overview on our representation. So we have quite a large membership base across Africa. As soon as we have enough members in a specific country, we start a chapter in that specific country. So just quickly to highlight some of our active chapters, we have our Ivory Coast, Ghana, Nigeria, and Cameroon, Uganda, Kenya, Rwanda, Zambia, Zimbabwe, and South Africa, just to name a few of the chapters where we are active. So I will share a few links in the chat as well to show you how you can get involved with ASIN and join our network and keep up to date with anything related to circular economy in Africa. So that was just a quick highlight of ASIN. I think now we can jump into the meat of this session, and I'll hand over to Piotr to get us started. Enjoy, everyone.
Yes, thank you, Christo, and good morning, everyone. Very much welcome everyone to this webinar that is kindly hosted by ASIN. And let me just make this big screen. Okay. All right. So yes, the webinar hosted by ASIN and is part of. Not yet. Sorry. Okay. Now, no. What do you see, guys? Sorry. Oops.
It's full screen. It's good, Piotr.
It's good.
Perfect.
Okay. So yes. So sorry. Yes, welcome again. And so my name is Piotr, and I'm the project team leader of the project called BUGS. BUGS is a project funded by the CCAC, so Climate and Clean Air Coalition, and we do this project together with EAVAC, ECLOS. The leader of the project is Africa Circular, and also we do it with Carbon Turnaround and Trinomics. And it's also co-funded by Prevent, as you see here on the slide. So today, we wanted to connect the community of practice that exists, and many of you come from that WhatsApp group, a big WhatsApp group that you maybe are a member of. So the big WhatsApp group is BSF Community of Practice, mainly Africa, but we have indeed members of the Community of Practice from all over the world. Many of them, most of them are already practitioners, many researchers. Also we have city authorities. We have some simply people who are very much interested and planning to be maybe involved in different roles in the BSF sector. Over 1,300 members so far, and it's the WhatsApp group. This WhatsApp community of practice is divided into 4 channels. Yeah, that is funding and employment, matchmaking, news channel related to BSF, and troubleshooting. The last one is possibly the most lively, because that's where peers, practitioners as you, exchange information, exchange also their troubles and their solutions to those different troubles. Because yes, as you know, the technology is still emerging, and it's still quite open for new interesting insights and maybe solutions. So we see that in different regions of the world, based on different conditions, available material, weather conditions, and so on, people, adapt, and that's very good. That's exactly what the beauty of the whole technology is, that it's adaptable to the conditions locally that are locally present. Some conditions are too hard also to kind of overcome. So we can also speak about that, but in the future sessions as well. So there were already a few webinars of this kind, of community of practice, and we will continue. There is also one channel in French. So if you prefer speaking French, there is a channel in French where you can also join and exchange. And we will also organize webinars in French. Okay, so if you are not a member of the community of practice, you can just scan this QR code, or maybe my colleague can just enter, please, a link with which I can do that later too, in the chat. So you can click and go to it will bring you to the WhatsApp community of practice. So just very quickly about overall the BUGS project. So it's been there almost 1 year already, and 1 more year to go. We focus on 3 countries: Cote d'Ivoire, Ivory Coast, Uganda, and Ethiopia. But those findings in those 3 countries are very much relevant also for other subtropical African countries. And we get a lot of collaboration ideas, and also already, practitioners like maybe yourself are approaching us to work. So we want to expand to other countries. But there are 3 main objectives of the whole project. First of all, is to work with national and local governments so that they prioritize the BSF technology for reducing methane emissions. So it's let's say high-level political strategy to reduce climate emissions. But of course, we all know that apart from climate benefits, there are also other benefits of black soldier fly. So, but there is a second outcome that we also focus a lot these weeks. So we go to each and every country, and we do a series of workshops with practitioners. We show to them how black soldier fly production can be done more efficiently, with a specific approach that we call SIMBA, which is Simplified BSF Approach. And the third point the third outcome is that we will work with those countries, with those national or local authorities, to expand, scale out the BSF interventions. So, but today we focus on substrates, okay? So as you see this infographic, it shows like different activities around black soldier fly. You see production, you see sorting, you see reproduction also of the flies. But it's the first part of the, if I can choose, yes. if you see this part, so where do we get our waste, our substrate, our feedstock for larvae from? It can be from farms, right, from markets, or from households. So we dive deeper into this today. Indeed, there are just a teaser before we go into a longer presentation of Muriel. We can get municipal organic waste, agro-industrial waste, manure, and even feces, also human feces. So those different substrates have the characteristics, they have their pros and cons, and it's very important to understand those substrates, how they could be mixed together or not, and then how what outcomes we can expect if we use those substrates. Because there should be a good balance of nutrients in order to have a healthy colony. How about water content? Is it a load if we have plastic inside or other inorganic chunk? And also accessibility and seasonability of those available substrates. So yes, mostly, you know, many of you look into food and kitchen waste, which is probably the most nutrient valuable. But also, yes, feces, pig manure, it's quite common in the regions where we work. Market or industrial waste, food processing waste. These are huge quantities that one can get in huge amounts quite regularly. But yes, how to ensure those substrates coming in, yeah, you know, setting up contracts and so on. There is also quite a lot of demand for this kind of substrate. We can talk about that. And what should not be given to black soldier fly? We will also speak about that, mixed waste and also waste with high fat content. So also, yeah, fibrous waste. Of course, when we think about substrates, we also have to think actually what is our main focus? Do we want to focus on larvae for aquaculture or for livestock, or for actually we just focus on the frass? So all those, like what we want to achieve, is also important to take into account. That's why within the project, we also do very detailed assessments, feasibility assessments. We choose certain region or city or a village. We analyze the situation from waste availability perspective, from weather conditions, market readiness, also people's perception, and also regulation when it's related to more the national level or local level as well. So regulation. So we do those assessments, and we already did quite a lot. And the template for those assessments is also available on our website, where you can find it and use this template for your own needs. So this is the website. It's on the CCA. If you Google CCAC bugs, it will get you to the website. So just to finish once again, to show you this community of practice that if you are not a member yet, please join, so that we can exchange there constantly. Everyone, it's a moderated group, just to say. So me and Daniela, who will also speak today, we are moderating along with a few other colleagues. But everyone basically can post and put a question that they want. We also have other interesting materials for you, for practitioners, like yes, a toolkit for practitioners that is available. You can see there are some deep business models, analysis, different, how to choose your business model, KPIs, standard operating procedure for the SIMBA. SIMBA stands for Simplified BSF Approach. Yeah, and basically that's it. The main point to discuss today is substrates. So I will invite now our colleague from Africa Circular, Dr. Muriel Eke, who recently did a study on substrates. And then we will also hear from Daniela to walk us through the Substrate Navigator, which is a web-based tool to also check what substrates what happens if you mix substrates, like what are the nutrient values and so on. And then we'll hear from practitioners, notably, first of all, from James from Kenya, but all of you, as we will have quite some time for a question and answer, we will we will exchange with all of you on your findings or situation, wherever you are, if you are in Africa or or elsewhere in the world. So thank you, Christo. This is just one photo from our recent workshop in Uganda. But Christo, I can now over to you and Muriel.
Excellent. Thank you
I
very
stop
much
share.
for that, Piotr. Really appreciate it. I think we can jump directly to you, Muriel. Please go ahead. Floor is yours.
Okay, thank you, Christo. Hello, everyone. So as Christo and Piotr said, I am Muriel Eke, and I do. Can you see my screen? Because I'm not sure.
Not full screen yet.
Okay, I'm doing that. Okay, it's good.
Perfect.
So I'm a former PhD student. So I finished my PhD last year, and I started working at Africa Circular since few months today. So we are going to talk today about substrate, what substrate can be used for black soldier fly farming, rearing, because Piotr said a lot of things and showed some substrate, but we are going to see that not all of these substrate are good for the rearing of black soldier fly larvae. So as I was saying, we are going to talk today about substrate, which is one of a key factor for BSF farming success, because there are also other factors that are very important to ensure good rearing of black soldier fly larvae. So as we know, due to the if we see this, we will talk that this is waste. This is disgusting and annoying because as I said, it is waste. But for black soldier fly larvae, it is a good resource that they can use to upcycle some important nutrients that are still in this waste. So, as we know, the population worldwide is increasing, and this increase of the population is leading to an increase in food waste generation. And this situation is most important in developing country, where 2/3 of the food waste generated is neither collected nor treated. And this, as we all know, cause some important environmental problems, like increase in greenhouse gases such as carbon dioxide and also methane emission. As we all know here, black soldier fly larvae is important because they are able to help us deal with this food waste generation by reducing this food waste. And also they are very important because the larvae, when they deal with this food waste, they grow, and the larvae are rich in some nutrients that can be important in animal feed. And alongside the fact that the larvae are important can be important in animal feed, there are also some byproducts that we can produce when we do the rearing of black soldier fly larvae, such as fat and some other important elements. So today, the main focus of my presentation will be the substrate. Why the substrate composition is important. Black soldier fly, as Piotr said, they are able to be reared on a wide range of organic waste, but this the substrate composition is very important because it has an influence on the larval growth, and it also has an influence on nutritional composition of the larvae. So I'm going to present to you one study that we conducted when I was doing my PhD, we assessed the effects of food waste composition on the growth and also the nutritional value of black soldier fly larvae. So the goal of the study was to evaluate how different food waste mixture can affect the larval growth, the bioconversion efficiency, also the nutritional value. And the focus was on the mixed substrate. We used food and vegetable waste. We also used potato scraps and forage. So these are the composition of the substrate we used. So as I said, we have food and vegetable waste, potato scraps, and forage, and we did the mix of food and vegetable with potato scraps, and the mix of food and vegetable with forage, and also the mix of the tree to see what could be the influence on the larval growth. So we had two main results that we obtained. First of all, we saw that the substrate that was composed of the tree substrate containing food waste, food and vegetable waste, potato scraps, and forage, we obtained best performance on the larval biomass, because the larval biomass was the highest and the mortality was the lowest, and also the bioconversion was the highest with this substrate. But the worst substrate was the substrate composed of 100% of forage, because we obtained the lowest larval weight and also the lowest bioconversion rate. And this is because this substrate has higher lignocelluloses content, which is very difficult to be digested by the larvae. So as I was saying, the substrate composed of the three, meaning food waste, food and vegetable waste, potato scraps, and forage, we obtain the best, the highest larval biomass, and the substrate composed of only forage was not good. And also, talking about the protein content of the larvae we obtained from this substrate, we saw that the protein contents were among the protein level of the soybean and also fish meal, which means that as it is not new for anyone here, these larvae can be used to in animal feed. And also we saw that the fatty acid content were specifically rich in lauric acid, and there are some fatty acids that make this black soldier fly larvae not good in terms of fatty acid, because they are not the fatty acids that are good for I will take an example of in chicken feed. We do not obtain this fatty acid among the fatty acid in black soldier fly larvae. So as we obtain lauric acid, we saw that it maybe played an important role in antimicrobial to protect the larvae from the microorganism in the substrate. So this is the reason why this fatty acid is found in black soldier fly larvae at very high content. And this lauric acid can be also valuable in cosmetics industries. So they are also look into the literature to see among the African continent, to see whether there was another there were studies on substrate, good substrate on for the black soldier fly rearing. So I therefore found this study of Kofi and collaborators in 2022, in which they analyzed some fruit to see their composition. And the key results they obtained, they saw that banana, avocado, orange, papaya, watermelon, and cucumber were good substrate to be used in to be used as substrate for black soldier fly rearing, because they obtain some important nutrient on this fruit. So as Piotr was saying in his presentation, that we have a lot of substrate that can be used for black soldier fly larvae, but you have to be careful, because if you do this if you produce a black soldier fly larvae for animal feed, you have to be careful and look into your region or your country if there is some regulation that guide this animal feed industry. Because in Europe, for example, there are regulations that guide this animal feed production, and black soldier fly or insect farming is put as novel food. So there is a regulation that told you what substrate can be used and what substrate cannot be used. This is not because of the fact that the substrate will have an impact of on the larvae. No, it is because of the biosafety of the product, because you will have to use this your final product to feed animal, maybe pets, or animals like chicken, which is also going to be used in human feed. So it is because of the biosafety of your final product that you will produce. So be careful to look in your region or your country if there is regulation on this. So as I was saying, in Europe, we have substrate restrictions, as animals can only be reared on substrate that are either vegetable based or specifically permitted animal origin materials, such as fish meal or hydrolyzed protein from non-ruminant. So you see that in the European Union, there is regulation to guide this insect farming. So when you choose your substrate, you also this is also important, because the larvae microbiota, it will also have an influence on the larvae microbiota, because the microbiota of this larvae, when the substrate is not good, it means that the microbiota of the larvae will not be able, as we saw with the forage, that it was not good, because the larvae do not have the microbiota to digest cellulose. So it is also one reason that it's important to look into before choosing your substrate. So to end with this presentation, I will say that among this, alongside the substrate, there are also other factors that are very important. So the substrate is just one factor among the other factors. So you have to control your the temperature of your rearing site or your rearing room, the moisture content also of your substrate, the relative humidity, and also the light, because all those parameters are important to take into account. So it is therefore what is important to retain or to take from this presentation is that it is not a new thing to everyone here that black soldier fly larvae can turn household waste into valuable protein and can reduce by reducing food waste. And we saw that when we mixed substrate of different type, it improved the growth and also the growth of the larvae, and also it improved the waste conversion. But we saw that you have to be careful on the fibrous substrate, because those substrates are not digested by black soldier fly, or difficult. The black soldier fly larvae have difficulties to digest those type of substrate. So all this technology on black soldier fly support circular economy and sustainable agriculture. So thanks for listening, and I will be glad to answer your question maybe at the end. I think the question it is at the end of the whole. Okay, I will stop. So I will hand over to Crystal to continue. Thank you.
Perfect. Thank you very much, Marielle. That was very insightful. And what stood out for me there when it comes to circular economy applications is just that shift in view that something isn't a waste. It's a resource that you can utilize. And I love that slide that you showed with the organic waste, which people normally veer off from. And it's actually such a valuable resource if you just know how to utilize it. So thank you very much for that. And please, if there's any questions for Marielle, please leave it to the Q&A session at the end. And then if there's nothing else from your side, Piotr, I think we can jump over to Daniela.
Super. Thanks so much, Crystal. Thank
you,
Piotr. And thank you, Asen, for inviting me. So now that we got kind of a deep dive into Marielle's substrate study, I'm excited to show you all the substrate navigator. So I'm just going to share my screen. Okay, can you all see my screen?
Yes, that's clear.
Okay, so I think I just lost you guys. Oh. Here we go. Okay, super. So the Substrate Navigator is a website or tool platform that we have created online, and we've collected studies from multiple people. So for example, now knowing Marielle's study, we would take this study and put it within our Excel and then upload it to the Substrate Navigator. And so the idea behind this tool was really for practitioners or also researchers, if you're interested, to understand how well do larvae perform on different types of substrates, right? So if for example, you have food waste and chicken manure here, and you just want to get an overall idea, how well are the larvae going to perform on this? You could go on the overall performance, click on food waste, and it'll tell you kind of, it gives you a high performance, whereas chicken manure gives you a medium performance. So what does this really mean, right? So you see that and you want to know, okay, high performance, is that good? Is that bad? Medium, what does that mean? You would click over to your raw performance values here, and you would click on that substrate. So you would go down to chicken manure, and I mentioned, I think, food waste. And you can select different larval performance indicators. So we've heard a bit about bioconversion rate, which is essentially the amount of substrate that they're able to convert into insect biomass, right? We have the fresh larval weight, the survival rate, the waste reduction. So let's say we want to look at the bioconversion rate. You would go here and you would see, based off of studies that we have collected so far, this is kind of what the average bioconversion rate is of the larval performance on food waste. So here we see that the average is around 27% dry mass. And if you wanted to see the studies, you would just click on the bar and it would give you the studies here below that we used. So with black soldier fly larvae, it is such a hot topic and there's always new studies such as Mariel's that just came out. So it's hard for us to also kind of keep up to date with all the studies. But we try to do as best as possible. Here you would also see that chicken manure, for example, has an average of around 7.5%. And so when we say variability, what we say, as you can see here, it says variability low. That means based off of the studies that we've collected, there wasn't such a big difference in how well the larvae performed in terms of the bioconversion rate. And so sometimes if you click here and you don't see the larval performance value that you're looking for, this just means we didn't find a study with that particular performance indicator. If you're also curious to see kind of, okay, well, what are the nutrient values, right? So how well, for example, let me just click here, go to food waste as well. So if you want to see, okay, well, what is the protein content that people typically get on these types of substrates? You could see here, for example, on the protein content of the larvae for chicken manure, we have an average of around 38%, on food waste around 39%. You could also see the fat percent of the larvae. Mariel talked about the fiber content of the substrate, right? That higher fiber maybe isn't the best. And so here you could also see, okay, well, what is the fiber content of that substrate and what is the protein within that substrate? Something that you cannot do with the Substrate Navigator is unfortunately do formulations. So we have seen, of course, a lot of papers on different formulations that have been used. However, we weren't able to really put that in here because it would be difficult to kind of put all the formulations under one category or one kind of substrate when so many people use very different variations of formulations. So for example, if you're using, 30% pig manure with 70% food waste versus what Mariel was using, you're going to get different values. And so that's one of the limitations of the Substrate Navigator. But the idea is really for anyone who wants to know how well do larvae perform on certain substrates to be able to go into this navigator and really kind of get a better understanding before even being able to test it. So that in a nutshell is the Substrate Navigator. I don't know, Piotr, if I should go into any more detail on it.
Well, I don't know, let's see maybe questions, but I just wanted to add that
Yes.
on the right top corner of
Yes.
that page that you showed, there is actually instruction how to use
Yes.
this Substrate Navigator. Because I know it might be complicated. It's very useful.
Yes.
Yeah, that's it, exactly. Mm-hmm.
Yes, so here we have exactly as I mentioned before. So here it's just really to kind of go in and discuss how to use it, what the raw performance value is that we discussed, or I discussed, what we mean by when I say the overall performance score, what does that take into account? So it looked at all the performance indicators that were available for that substrate and it basically gave them an equal weight, right? So we didn't say that one is better than the other, but we just wanted to give an equal weight to then be able to give an overall performance score, which is what you saw with the high versus medium. And then it also discusses here the nutrient value, right? So what's the nutrient composition of the substrates that we were able to get based off of literature? And then what, of course, are the protein and the fat content of the larvae on that specific substrate. And so, as I mentioned, if you don't see it in here, it's most likely because we did not find a study at that time that contained that value. And then, of course, if you're interested, if you're a researcher and you're interested more on what the statistical analysis that we used in order to kind of generate these performance score calculations, we go into more detail here on the different method that we used. If you want to know more, as I mentioned, on, for example, where the studies came from, you just really click on the bar. You can't see me click on it, but that's what I did. And then it will give you all the citations of the literature that we use to be able to program this. So as I mentioned, there's so much literature out there. So it's hard to keep it up to date, but we try our best. And if there's any, questions on it, I'm always happy to share more. We are currently having issues still with our mobile application of it. So it's really just on the computer desktop where you can be able to use it best. Unfortunately, yeah, we're still working on the mobile aspect, but on the desktop of a computer, it works well. And then you can, of course, just refresh and start over if you want to. Now, you can also select the classification if you're only interested in animal manure, and then it will only give you the substrates that we have based off of those. Or if you want to see all the substrates, then you just click all classifications and you'll have all the substrates that we found within the literature that we thought would be of interest for people. But like I mentioned, if you want to know more or want to understand again, just click on this gray icon right here on the right top corner, and it will tell you how to use it, our contact information, and the statistical analysis that we used. And of course, if you want to cite it at all, here's the citation. Great. So I'm happy to answer any questions more on it. But this is really just for everyone to be able to understand more about what substrates are available, what the performance is of the larvae on these different types of substrates from all the literature that's been out there from different types of researchers, such as Marielle herself. Thanks. I give it back to you then, Crystal. In case there's any questions, feel free to write in the chat.
Excellent. Thanks so much, Daniela. That is an incredibly useful tool. And I can see there's a lot of effort that went into that, especially gathering all the data on all the different substrates. That's incredible. So thank you very much for sharing. We will definitely share this after the session as well for everyone that registered for the session that cannot make it. And we can head over to our next part. So we'll hear a bit about our black soldier fly practitioners' perspectives. So firstly, I'll give James from Kenya the floor to chat a bit about his operations that side, and then I'll also open the floor for any other practitioners that's on the call to please jump in. I think between this session and the next one, we can actually open it up for the Q&A session after we've heard some perspective of practitioners. So the floor is yours, James.
Hello, everyone. Hello.
Yes, we can hear you well, James.
My name is James. I'm a practitioner of BSF. So briefly, I'll go through what our farm is and what we do. So our farm mainly started with the chicken farming. But now, because of the problem of feed for the chicken, especially protein, which was very expensive, soya, fish meal, and all that, we had to think of an alternative. BSF was a good solution. So the name of our farm is Chess Farms. So from the name, cheap, effective, self-sustaining. That's what we modeled our farm on. So I'll just give a quick overview. So we have the chicken, the BSF food for the chicken, protein mostly. Then we have biogas, which we use the waste from the chicken, even the BSF frass, we can use it on the biogas to produce the energy we need on the farm for warming chicks, operating machines, such things. Then we have a greenhouse coming up for groceries. We plan to use the BSF frass on the greenhouse. So that's basically about our farm. There's a lot more, but because of time. So for the BSF specifically, the substrate, which is the topic for today. Sorry, I forgot to mention, I have some medical background. I'm a medical doctor, so I know a bit about nutrition. So what we've noticed with the substrate, for size and fat content, if you have a substrate that's rich in starch, like let's say fruits, which are rich in sugars, which are starch, or if you have potatoes, anything starchy, the larvae tend to grow bigger faster. And now for us, we mainly use the fruit waste because of the starch. It's easily available from the market. And now we mix it with the chicken waste because, as you know, I don't know if you know this, but chickens are poor digesters of feed. So whatever they ingest, around 50% of it will come out as undigested. So whatever we feed the chicken, if it's high in protein, 50% of that will come out as protein still. So when we give it to the BSF, the protein content will be a bit high. So we mix, so the fruit waste is for the starch and the fatty bit of the nutrition, which makes the larvae grow big. But because we're on the farm feeding chickens, we need the protein too. So the protein from the chicken waste is which is half digested, will now come into the BSF now and go back to the chickens. So we prefer the chicken waste because of the moisture content too. It's not too high. So when we mix it with the fruit waste, which is high, has a bit of high moisture content, we can regulate the moisture content to a level which, because our target is to have a bit of dry frass, so that processing is a bit easy. Easy to separate from the frass from the larvae, so easier to feed and all that. So and then our other ingredients, we add a bit of grain-based waste like brewer's waste, because of the fermentation effect it has. It actually increases the heat a bit in the substrate, so it aids in drying a bit faster. So we've noticed brewer's waste and anything that's grain-based, like brewer's waste, or I would say, like if you go to a miller and the waste that's on the floor, the powder form, that really helps with the fermentation and the heat content to help dry the substrate faster. So for us, because we are doing mainly for the chickens, we were focusing on the fat content, which is from the starch, and the protein, which is from the chicken waste, which are poor digesters of food. So like 50% of their waste will have a good amount of protein. So that's mostly why we do that. So we've noticed the BSF don't do so well with the waste that has a lot of citric acid. I would say things like pineapples, oranges. I don't know if they don't prefer to eat it, or I don't know why, but we've noticed that. And also, if you have anything that, as my colleague Muriel was saying, high in fiber, it's hard to digest for them. So you'll find at the end of the day, after they're done with the substrate, there's a lot of fiber in the substrate. And also, if we've noticed that if the substrate does not have has something that the BSF cannot digest, it also contributes to the moisture content being high at the end of the feed. So you'll find the BSF are mature, but you still have a high moisture content. For example, we've noticed if you take chicken waste that has sawdust in it, the frass will not dry up because the sawdust is not digestible to the BSF. That's what we've noticed. I don't know what the research says. Yeah, that's what I would say about the substrate. We used to put in to add this waste from slaughterhouse, but we noticed yes, it's actually really good because the protein is a lot in that, but it was too wet. We found at the end of after the BSF had done eating the substrate, we had too much moisture at the end of the day. So that's why we shifted to the market waste, mostly fruits or anything that's rich in starch, and the chicken waste. So they're very good. They're actually very complementary, because even in the chicken waste, it has, because chickens are, as I said, are poor digesters of food, so it still has some grain in it. It's not fully digested. There's some form of grain in it. So it actually, when you cover up chicken waste for maybe a few days, you'll notice there's a lot of heat coming from it. So that also helps in drying up the substrate, and you end up with a cleaner product at the end of the day. So, and the way we've designed our farm is we are not so much into details. It's a simplified, easy, farmer friendly. We don't weigh so much. We don't go into the nitty gritty so much. It does come with experience. We know this quantity is enough for this amount and all that. So, and we plan to do more. We're just a bit, there's because I live in sort of an urban center, there's a lot of waste from the high population in the urban center. But our main challenge has been about collection, because there are different markets around where the farm is. So we need maybe something for better collection. And then, as Muriel was saying, also, apart from substrate, temperature is very important, and light, and humidity. Although we've noticed humidity is a bit hard to maintain, because they need around 70% humidity around there to be optimally productive. So for our BSF, they are completely housed in a greenhouse. So with complete climate control. So the temperature inside the greenhouse is completely dependent on us. We have no open areas, like we have curtains around. So we open and close them as per the temperature. So that's another very important factor. So you get, in a week's time, we come from Insta 5, the 5-day-old. Sorry, not Insta 5, Insta 2, the 5-day-old larvae, to the Insta 5 in a span of 1 week, because of the temperature we control in the greenhouse. So unless there are questions, I think my closing remarks would be, for us as a farm, we are designed as a circular economy integrated farming. We plan to have pigs also, and fish ponds, because you see, with BSF, we can feed fish, we can feed the pigs and the chicken. And we are looking forward to working with similar-minded partners, and help clean the environment while having food security, because with BSF, it reduces overfishing, because there's a lot of fishing now, food for animals, for people, so there's competition. So if we have BSF, we can reduce overfishing, we can clean the environment, we can reduce greenhouse gases, and also it can reduce pressure on the farm, like over farming, and we can use some land for other things, maybe population, houses and stuff. And also, because we are producing frass, which is it's a natural fertilizer, so it protects the soil, not like the commercial ones. And also there's another product now, the shells of the emerged pupa, the emerged flies, is rich in chitin, and the chitin can be used as a soil conditioner also, or is actually rich in calcium, can be used as a food additive. So we have a lot. Thank you.
Thank you, James, for your insights. The perspectives of practitioners are really very, very valuable, and I invite everyone, because here who is practitioner, because maybe I'm sure many of you sympathize with this situation, the different challenges you have. And I noted few of them, but I would like to, ask everyone to also share quickly. You can, I think, Christo, we can invite them to, everyone to just raise hand, and then we'll give you the floor. But I just noted two things. One is about some of the substrates being too acid or not. Maybe the solution is simply being aware of that and mixing more, right? And then humidity. I guess one of the solutions can be simply maybe that you don't put enough larvae inside your batch. There were also two questions from the floor regarding the chicken waste. So how do you reduce the smell of chicken waste? Or also whether the hatchery chicken waste is also possible to use. But maybe you just note those, James and Daniela and Moriel, the questions, but we also have someone now raising the hand. Over to you, Christo. Just wanted to react on some general.
Excellent. Thanks so much for that, Piotr. I think we can hand over to, sorry, apologies if I mispronounce your name, Ozam Wambu. Your hand was first. Go ahead. You can unmute and ask your question.
Yes, good morning. Can you hear me?
Yeah.
Loud and clear.
Yes, I'm from Nigeria. I'm in university. I'm a researcher trying to venture into BSF because I'm into waste management, solid waste management. So I reached out to Piotr some weeks ago. I don't know if you could remember on LinkedIn when I saw the training in Ivory Coast and Uganda, and I was asking how can I join the training or how can I register to join, because I noticed that we don't have something like that in Nigeria yet. So I'm still asking, how do I join? Okay. How can I join the training in Uganda? And two, is it possible for me to bring this training home to Nigeria and to my city? Because we have lots of organic waste here that we need to take care of. Thank you.
Okay, maybe I can just quickly address that. So yes, thank you. Many people from around Africa reach out to us to do those trainings in person. We have to focus on the three for now, okay? Inshallah, it's soon. We will also have one in Nigeria and in Chad and in Mali, because many people ask. But what I can share, I will share now a link to the training materials. Okay, you can already study them. Everyone can study them. And I hope we will be looking for funding to also organize it in your country. But for now, we have to focus on the three countries and the people that live there.
Okay, thank you.
Excellent. That's great news. I'm looking forward to seeing that training material, Piotr, as well. And then the next in line is Maj Anderson.
Yeah, thank you. Hello, everybody.
Yes, we can hear.
I am Maj Andersen. I'm a researcher at the University of Copenhagen in Denmark. And I'm also heading a research project, a new research project in Kenya called GECOSIR, where we are seeking to valorize food side streams. Where we are using a kind of pressing filtering technology, so we're not using black soldier flies. So my more fundamental question is this discussion of linking up the circular economy to the bioeconomy, and how do we actually decide how to use the substrates for what purposes? So when should we use black soldier flies, and when should we use other technologies? And it seems very little researched. So, and I am not looking into black soldier flies in my project. We don't have the research money enough for this, but obviously it's a very interesting alternative to more technological solutions for how to valorize and upcycle food side streams. So I would like to ask this audience of black soldier flies experts, how much you are also considering moving into this, also even discussing whether algae is a better alternative than soldier flies and these other more technological solutions when we want to upcycle and really also move into biocascading. So when we are looking with a specific substance, we call them food side streams in our project. What's the most optimal way of valorizing a mango peel or a mango seed and so on, yeah? And so obviously both for corporate strategizing and for policies, this matters highly, so we don't invest in the wrong infrastructure. I mean, we want to build up a good infrastructure and good policies for valorizing these biowaste more generally. So this is my more fundamental question that I'd like to start with. I also have other comments, but I'll wait for those. I hope that made sense. And anybody interested in knowing more about my project, you're welcome to contact me afterwards. And I'm very interested in you, John, from Kenya. I would love to, James, sorry, I would love to hear more about your project, but that's another story. Thank you.
Thanks. Should I go ahead and answer? Yeah.
Please go ahead.
Cool. So I think for, determining whether basically BSF is the right kind of technology opposed to the other different treatment technologies such as biogas or composting. We say that there's 4 fundamental kind of categories that are important to really look into, right? So one being, I can actually share my screen because I have like one slide on this. Can you see my screen?
Yes, we can see.
Yeah. Mm-hmm.
Great. So we say that there's kind of 4 main categories, right? One being, what's the waste available? So as I mentioned in the, can someone mute? As I mentioned with the Substrate Navigator, kind of looking and seeing, okay, what substrates do you have available and how well do the larvae perform on this, right? So it's important to know what is available and what is accessible. And also with BSF, one of the things is that they're quite sensitive, right? So it's important to know, are there other factors that might influence your performance, such as the seasonality? Is your, for example, food waste that you're getting from hotels dependent on tourism? So maybe in summer you have a high surplus of food waste, but maybe in the winter you have lower, and that means you have to have other types of substrates. What is available there and how well are the larvae going to perform on that? Then we also say about the purity, it's important, as it is with, for example, composting, that it's really source separated from the beginning, right? We don't really want mixed waste because with mixed waste, you have a higher chance of contaminants, right? So if you can have your waste already source separated from the beginning, this reduces the risk of contamination, which then reduces the risk of your larvae being contaminated. We also say understanding kind of what is the regulatory framework within different countries. So for example, I know in Uganda now insect-based feed is kind of part of the animal feed bill, right? So it's not restricted for use of animal feed, but it's important to understand, is it in other areas? So depending where you're coming from, also, is it easy to do business there? Are there certain things that you have to kind of assess, and who are these stakeholders involved within your context? So that's kind of also a really big important understanding. And then of course the operations and management we talk about. So BSF operate best within a temperature range of around 25 to 30, right? So if you can kind of maintain, if your climate is within this temperature range for most of the year, then you have a nice temperature range or a nice environmental condition for your BSF. Also, what's the space and equipment that you have? So the great thing about BSF compared to other treatment technologies is that you can really make it flexible and adaptable for you. So there's different types of scales. You can work, for example, Piotr mentioned before the SIMBA, which is our simplified BSF approach. This is more for scaling of around 250 kilograms of waste per week, right? But we see also facilities that, for example, can do 1 ton of waste per day, up to around 40 tons of waste per day. This would be kind of a medium-sized scale. And then, of course, there's these industrialized scales, which are more the 700 ton. And this, I think, is more, do I have a... This is what I'm talking about when I say a medium scale facility, right? So this is the 1 to 30 tons of waste per day. And then of course, there's a large scale where you see these big kind of industrialized facilities, but this is more, I would say, within the European context that we've been seeing this, and not as much within the African context. But the last one is also just understanding what are the market opportunities. So we have found so far that, for example, in Malawi, a lot of farmers don't know about BSF, but are interested in understanding how it is, how they can use it. So it's important to kind of understand what's the market for the product within your region or your context. And if there's any market supporting mechanisms there, right? We hear now some facilities, for example, I think Chanzi was approved with carbon credits. So they're looking more into that as an additional revenue source. And so it's just important to kind of understand these different, what are the different markets that are available. But we have a whole guide that goes more into detail on this and really understanding what's the feasibility in order to determine if BSF is right with you in your context, which we can put in the chat. So yeah, hopefully that gave kind of more clarity on how to determine if BSF is kind of right. And it's just an important factor of, whether it's BSF or you decide to do biogas or you decide to do composting. It's really understanding all these different aspects of determining which technology is the best one.
May I add to that one?
Yes.
Is that okay? It wasn't quite what I was looking for. I understand fully
okay.
your arguments,
Okay.
and they are valid. But I was also trying to ask into these cross-cutting studies, which discuss critically when to use black soldier files versus other valorization opportunities. And I'm actually not looking into composting or biogas because I consider these downcycling, but more high-value valorization, such as using filtering pressing technologies, as well as algae production, which I consider the most high-value, together with black soldier flies and insect production more generally. So I'm seeing a research gap there. And I was wondering whether you found that research gap also in since you're looking so much into the literature so I'm looking for that research gap, and it seems research groups and even practitioners are either doing algae production or they're doing black soldier flies. And researchers are really not, and it's also very early, this research overall. There's very little, particularly food to food upcycling research. So that's what and since we're also looking into now investing in these and even supporting them politically, it matters at an early stage to discuss, okay, are we going the right way? And how can we combine black soldier flies with other solutions? If we're thinking about building circular biorefineries, food bioparks and so on, which is what I'm working on and intend to do more research into also in Kenya. So how do we situate black soldier fly production within that wider setting if we want to go really high circular, where I think black soldier fly certainly has an important role to play. But for that, we would like that bigger picture. And I don't really see anybody, or am I missing something? Or and I would like to know how this forum of experts in this field that I'm not an expert in myself. Are you seeing the same thing as I'm seeing, or are you seeing it differently?
No, I get it. I understand. I think for me, anyone else can jump in if they have more of an answer to this one. I personally haven't seen that. So, for example, in my former PhD group, we work a lot on microalgae and BSF, but not as a combination. So it's always been kind of the microalgae group working on the food side streams, right? So using, for example, rice water as a potential side stream for microalgae. And then, of course, others of us worked on the BSF aspect and using more of this kind of food waste. But we did not come together as a group to see how we could kind of integrate it within the system together. The only aspect that I've looked at, but you mentioned that you see it as more of a downside, but is really the coupling of BSF with biogas, right? So for example, using the residue instead for biogas production, the residue from the black soldier fly larvae. But for other integrated systems that I know of, maybe there is research out there. I haven't really looked into this, but I have not seen so far. But again, I haven't looked so detailed into it. So yeah, I can't give a better answer for that. But if anyone else has seen that or has an answer, please also feel free to say.
Excellent. Thanks for that. Giving it a shot, and I really appreciate it. Thanks for your question, Marge. I think that might be a bit out of the scope, like Bill just said, for this session. But let's definitely catch up afterwards. And I think maybe there is a gap in the research somewhere that someone in the session might be able to take on or chat about afterwards. But I think for now, let's jump over to Diego. The next, if you have any specific questions on your side, Diego.
Hello all, thanks for the webinar. It was very interesting. I wrote the question in the chat so I can read it. So recently, several large companies in temperate regions with significant investment had filed for bankruptcy. The primary reasons cited have been insufficient market demand, high energy costs, and expensive logistics for transporting organic waste to production facilities. There has been considerable discussion suggesting that in tropical countries, energy and labor costs are substantially lower. Given your experience with black soldier fly production in tropical regions in Africa, could you share your insights on the validity of these claims? Specifically, is production genuinely more profitable in these areas, and are black soldier fly-based products gaining market adoption in African countries? And additionally, what are the main advantages, and especially what are the challenges do black soldier fly production face in tropical African countries?
Let me jump in. Diego, it's a very valid question, but again, it's not really in the scope. Let's hear from, no, it's a very important context. Huh? And maybe we set up another bigger, like another webinar on that. But let's focus on the substrates, please. There are questions about bread, about chicken. Let's focus really on that. So if you don't have a question about substrates, please don't ask it. So Chris, let's move on. Maybe Rimba and others. We can also read the questions from the chat because they are very to the point.
All right, good morning, everybody. Thank you for the opportunity to ask a question. I wanted to ask on substrates. I have not heard, I don't know if I missed it, on garden waste. Can black soldier fly deal with garden waste? And also, if the question is yes, what products am I looking for? And then what is the residence time in the different substrates that we can actually incorporate for BSF? Thank you.
Okay. So what's the development time of different substrates?
The residence time.
So it's time. Of the larvae on the substrate, right?
Yes.
Oh, okay.
Yeah. So the development time really varies depending on what substrate you're working with. So, for example, on high protein substrates such as food waste, right, you could see the larval development time, of around 10 days, for example, right? But if you work with something super high fiber substrate, such as like banana peels or cow manure, you're going to see that extend for a longer period of time, for example, up to even 30 days, and still not get a higher larval biomass. So it's super crucial to see kind of what substrate you're working with in order to kind of determine how long it's going to take.
Maybe
so I can't. Sorry?
Yes, so the reason why I'm asking on residence time is I have a project that I'm working on and there is a lot of garden waste. So I've been contemplating if I should go for BSF on garden waste instead of other solutions. So hence I wanted to know from practitioners and researchers around here if they've explored garden waste primarily.
Yeah, I worked with, like, for example, grass clipping specifically. And there we saw, we had to kind of chop it up finely, right? In order for it to kind of increase the larval performance. So I think the study we did was around 9 days on grass clippings. And so it depends how big you want your larvae to get also, because what we saw is you have to shred it quite fine. Ideally, you should mix it with a high protein substrate if you have that available with you. If you only have the garden waste available, and if it's quite woody, then I wouldn't really suggest it. because the larvae won't be able to degrade it properly. If it's just the grass that you have, so just really like these grass clippings, then I would shred it quite finely, and then you should see basically a better larval performance. But again, it still won't get to kind of the same weight that you would see with food waste alone. So either formulate it with other nutritious food waste or shred it. But Marielle, maybe you have other stuff you want to kind of add on.
Thank you, Daniela. Yes, that was the same thing I was about to say. And also James said that you can also mix with starchy waste. You see, if you have, you can have, as I showed in my presentation, like potato scraps waste. So you can also mix with that, because if you only use that, it will not obtain good results, as Daniela said, because the larvae will not be able to digest, to well digest all this type of waste. So
maybe to add on that. Hello. Yeah, to
Go
add
ahead.
on that.
Go ahead, James.
Yeah. So the question was also about time, the time it takes to process the waste to fully mature the larvae. So for that, we've noticed temperature has a big effect on that. So if you have the ideal temperature, it will actually take, for us, it takes like a week from 5-day-old larvae, which are like Insta2 to Insta5, now mature ones to feed. And then on the substrate, if you have a starchy feed, anything that's sweet, sugary, or basically starch, because now from biology, the larvae will convert the starch into fat, and the fat is now the size, the big. They'll grow big. We've noticed if you put it in a very sugary substrate, they actually grow very big, very, very big. But now you have to factor in other things. You're looking at this substrate to have a certain moisture content by the time they're done processing it, so that it's easy to separate the larvae from the frass. So you balance the size bit of it and also the substrate, the frass needing to be dry after we are done processing. So I would advise sorry, you said vegetable waste, right?
Yes, garden waste.
Garden waste, I would not, we don't use that so much, because number one, the larvae don't eat it so much unless you grind it so much to a very fine consistency. And also the nutrition in the garden, in the vegetable waste, is very low. It's very low in protein. If there is, I don't know if there is any protein in that. Very low in starch. So from what I've said about the size of the larvae being dependent a lot on the starch content, and now you need other things like protein depending on what you're doing with the larvae. Like for me, on my farm, I need to have a high protein content to feed the chicken. So you see, if I use that substrate, I'll have a very low protein, very low starch content, so the larvae won't be the right size.
Wait, there is an issue with connection there.
Sorry, I'm done unless
okay.
there's.
Yep. Okay. You hear the same, Christo? Okay, let's mute that person. Yeah, someone is cutting. Okay, if I can just drive the discussion, thanks, James and Daniela, also, and Muriel, to some new questions here about bread. That's indeed something I don't know too much. And then there is also a question about water hyacinth, and I'm just drafting the message now. Yes, we know that water hyacinth can work well. Of course, never alone. As any substrate, if it's alone, it will not perform well. But if it's mixed into a substrate, which has other nutritious values, it can work well, as it gives also the bulk structure that is needed in the mix, right? So yeah, Muriel, Daniela, do we have some information about bread and bakery waste?
Yeah, I think so. I know, for example, our facility in Uganda, they use some bread mixture. I'm not sure to what percentage of formulation that they use the bread waste mixture. The bread that they get is really just dry old bread. So that's why I mentioned in the chat before, since it's been just really dry, you can kind of add it to a more super moist substrate, and this can kind of help to dry it up a bit. So that's beneficial for the larvae. Because I think Mariel mentioned already before that the moisture content should be around this kind of 75%, right? So if you have a very moist substrate, you can use the dry bread. Someone wrote a buttery type of bread waste. This I'm not sure. I mean, I'm sure it should be fine as long as it's not super oily, but I think that's fine to kind of add it. And with the water hyacinths, also we see that you can add it into formulation. I wouldn't go above 20% inclusion on a weight basis, just because otherwise at the end it gets really quite difficult to kind of harvest your larvae. So I would say formulate it of around 20% wet weight basis, mixed with other more nutritious substrates. Does Mariel want to say anything else on either one?
Yes, I can add to that because me in my study, I work with potato scraps, so that have a lot of moisture, a lot of water content. So you can mix that with bread, as Daniela was saying, and with the potato scrap. When I use potato scrap, I mix around 25% with other substrate, and that was also good. 25% and also 50%, but 25% was good. So that is just what I wanted to add.
Thank you very much for those additions, Mariel. Let's maybe while oh, I see, Piotr, thanks for the fish waste one. So that's too oily. Anita.
I just wanted to add something.
Go ahead, James.
On the bread, I think bread is perfect because it has starch. And as I mentioned, starch is really important for their growth. And then as Daniela had said, because it's a bit dry, if you mix it with something that's a bit wet, maybe like fruit waste now, they're complementary. So it kind of reduces the moisture to the amount you need. But in my opinion and experience, bread is actually really good.
Excellent. Thanks for those inputs, James. So I see we only have about 5 minutes left. So I think the two hands that we have now might be our last two ones. So Adeboye, go ahead.
Hi, good morning. Can you hear me?
Yes, loud and clear.
Good morning. I'm from Nigeria, the southwestern part of Nigeria. I currently run a BSF farm, small to medium scale. I have a couple of questions, but I'll just try to wrap them up as quick as possible. So one of them is around the substrates for incubating eggs, right? And then for the nursery stage, in regards to what's the best substrates for that initial stage where you're incubating the eggs, and then when you are transferring the eggs from incubation to the nursery stage. That's one question. Another is for our stage right now, we get a lot of waste, and sometimes we're not able to utilize all of them at the same time. So we tend to dispose them off, right? And or we try to turn them to compost. So the question in there will be, what can we do when we have excess waste or substrate? What do we do with them when we can't utilize them? That's another question. One more will be for fruits, oranges, right? In my area here, we have a lot of oranges that go to waste, and we've not tried them exclusively, right? Maybe mix them with a little bit of brewery waste. But I want to ask, what's the research been when you're utilizing fruit waste for a substrate, especially oranges? I don't know if the acidity levels affect the growth of the larvae. I don't know how that works. So I want to ask if there's been any research done within that area. Then lastly, I want to know what's the substrate in terms of egg production, right? And the the quality of eggs. Is substrate directly proportional to what you get in terms of the production for eggs and also the quality? Is the type of substrate directly proportional to that? Thank you.
Can I jump in?
Go ahead, James.
So first question about incubation substrate. For that, you need a highly nutritious substrate because you're giving them the foundation for the rest of their life. So what we use wheat bran and brewer's waste. It works perfectly for us. But of course, you have to be keen on the moisture content. The hatching is sensitive to moisture. So we need basically you need a high nutrient substrate. You can use the market waste and all that, but it's not ideal. The nutrient is not the same, and it's not easily digested as the ones I've mentioned. Then when you have excess substrate, the second question, actually you're supposed to ferment it in airtight containers because that's like a pre-digestion. In fact, the longer it stays in those fermentation containers, the better, because as we all know, the BSF larvae don't have mouth parts. So it's easier for them to digest the fermented waste. So the longer, the better, actually. So the oranges bit, maybe I'll ask the researchers, but from my experience, citric acid, as I had mentioned, is not, from what we've seen, is not very ideal. Maybe someone will answer me on that. Then the last question, the substrate, as the relationship with the substrate and egg production. So there's actually a correlation because the bigger your larvae is from whatever substrate you fed it, the bigger the fly will be and the more eggs produced. So a single fly can produce between 500 and 1,000 eggs. So a well-nourished larvae, which will turn into a fly, will tend to produce a larger number of eggs. So if your substrate is more nutritious, you're more likely to get more eggs from your flies.
Thank you.
Thank you.
Excellent. Thanks a lot for that question and for the feedback, James. If any out of the other speakers or panelists wants to add anything, if there's nothing else, we can jump to our last question. Ahmed, go ahead. You have 1 minute.
Good morning. I will ask very fast. I'm just curious about the how frequent the feed is being added to the larvae during the life cycle. So is it once? Is it more than once? And if it is once, is it frequently moistened later on from a practical point of view, or is just with the initial moisture, it can continue to keep good moisture content until the let's say the pubation or the harvest, let's say. So yeah, from a practical point of view, I'm curious to know. Thank you. It's a very nice presentation, and it was a pleasure, let's say. Thank you.
Okay, I can mention kind of how we suggest from the AVAC side. So for practitioners, we typically say to give, so typically you would rear your larvae or your neonates, like your little baby hatchlings, for 5 days, 5 to 7 days on a highly nutritious substrate. So I think James mentioned he does wheat bran mixed with brewery waste. You can see if you can do maize bran. You can see if you can do kind of chicken feed. I know is expensive, but anyways, a type of kind of nice, highly nutritious substrate for those first kind of 5 days. And then we suggest to give them to what we call the incubator phase, right? So we kind of give a smaller portion of feed in a smaller container for around 3 days, right? So the moisture content is still the same, but just kind of less amount in a smaller container. And then we discuss to then move them after 3 days to a bigger container with more feed. So for example, I think we suggest with the simplified approach, so this approach of around 250 kilograms of waste per week, how much do we give? I think it's around 5 kilograms for the first in the incubator phase, and then 7 in the second feeding. So we suggest 2 feedings, but we can send the guides so that you can see kind of the exact amount and the amount of larvae that we also suggest to put with those feeds. But we suggest always 2 feeds and the similar moisture content. Maybe James wants to say how he does his approach.
So for our farmers, I'd say we are looking to simplify the production. We don't want to complicate it so much for farmers. So, but the ideal should be around 250 grams for like maybe 8 kgs of waste. And for us, we just feed it once. We feed it once, and after a week, it's like from experience, we know this amount will go for this amount of time, and it will be dry and be fresh by the end of that week. So we don't feed it twice. We don't feed them twice for ourselves. We just feed them once, a specific weight of larvae and a specific weight of substrate, and that's it.
Excellent. Thanks for that question, Ahmed, and thanks for the inputs, James. I also see, I think that there's multiple approaches depending on your specific situation, because I see Piotr also mentioned that they suggest actually to have a second feeding, but that probably depends on your specific operation. So thank you, everyone. I see we are a few minutes over already, but thank you. This was a very engaging and very valuable session. So thanks so much. Thank you very much for participating and for the active engagement. I think this is the value of sessions like these, is to interact and collaborate and share ideas and get connected. So please follow up on all these valuable engagement that was mentioned in the chat. I see a lot of contact details were shared, so please follow up afterwards. Read up on all this material that was shared. Thank you, Piotr, and the speakers for your time and sharing your knowledge. I think this was incredibly valuable. So then just a last from my side as well. Thank you very much again for everyone. And if you can please take a maximum 1 minute just to fill in the short survey. It's just 3 or 4 questions on this specific session, how you find the session, and give us some feedback to improve sessions like this in the future. So with that, I will close the session. Thanks again, and I'm sure we'll see each other in the next one down the line. Thank you, everyone. Have a great day.
Thank you.
Thank you,
everyone.
Thank you.
Thank you.